measuring research, particularly academic research, and I'm going to kind of go through the background, like, the historical timeline of how we've measured research up until this point, and then kind of talk about like what AltMetrics are and how they're relevant to measuring research. So, okay. So, why do we measure research and how do we measure research? And then what are AltMetrics and how do they fit into that? So why do we measure research? And what do we evaluate? How do we evaluate it? When do we evaluate? And how do we measure value and impact? So when I say we're pretty much talking about, the academic or the research world, and how do we measure value and impact is really key here, because I think we've kind of gotten away from what it is we value and why we're assigning value and impact to certain measurements. So this is basically a quick timeline of the historical development of measuring research, and kind of the original statistical bibliography, mostly for collection development purposes. And so the original citation measurements were really for library purposes of what it is libraries should have in their collection. So what journals should they subscribe to, and what should they have on their shelves for people to read. Kind of fast forwarding, because we started a little late. In the 1960s, Eugene Garfield and the Institute of Scientific Information came up with what is called the Journal Impact Factor, or the JIF. And so that's kind of mostly what we use at this point, is the Journal Impact Factor. I think Emily's having some tech problems. But there are different measurements, the different things that we measure. So bibliometrics is looking at published materials, such as articles, books, and journals, whereas scientometrics can look at more than just publications, but talk about data sets, groups of scientists or institutions, and then if info or informetrics kind of encompasses all of that. And within that, we have webometrics or cybermetrics, which is analyzing information that's on the web. But what AltMetrics does, and you might notice that it's not actually in this graphic, is that it's looking at scholarly impact based on activity in online tools and environments. So it's not looking at an actual piece of information necessarily. So modern bibliometrics, again, Eugene Garfield kind of came up with how we typically measure information today. And so the kind of key concepts, what we take away from this is what we're saying is important is productivity and impact. And the way we're measuring impact is citation as a foundation of scholarly metrics. So if I had students in the audience right now, I would stop and ask them, what do we mean when we talk about citations? Because a lot of times we talk to students and we ask them to cite their resources and talk about citations. But I think that there's already a disconnect from the academic world when we talk about citations and the rest of the world. But in terms of measuring impact, we're going to go into how it's measured citation by citation, but really how often an article is cited is how the impact of that article is measured. So basically, you might have heard of, publish or perish for scientists and for researchers. And really, they have to publish a lot, and they're often expected to publish in what are considered prestigious journals. And we'll see why that is very much an issue. But so in 1975, the journal impact factor was officially introduced in the journal citation reports, but the idea was first introduced by Garfield 20 years prior to that. And like most things, he said that like nuclear energy, the impact factor is a mixed blessing. I expect used constructively while recognizing that in the wrong hands it might be abused. So he had a vision for how the journal impact factor would be used and how it could be used, correctly. But like a lot of things, it was kind of turned on its head, and it's complicated, and it's not really measuring impact, in my opinion. It's not measuring value of research. So I honestly thought that going into librarianship meant that I would never have to do math. And unfortunately, math is very much a part of daily life, and especially when we talk about measuring journal impact. So I'm going to read through this because that helps me kind of get my head around it. But for the journal impact factor, a number of citations generated by each citable item or an article as calculated over a length of time. So typically the time is 3 years. So the number of citations in a current year, so 2019, divided by the number of articles over a period of 2 preceding years. There's a typo in that, I apologize. It takes into consideration the size of the journal, so the number of articles that journal publishes every year. So 2019 journal factor would look at the citation, so what is cited in 2019, based on those citations that were published in 2018 and 17. So the number of times articles were cited in the current year over the total number of citable items published in the journal in 2018 and 17. So if you have 640 citations generated by 240 articles, because you're saying that if 10 articles are published a month, 10 articles times 12 months times 2 years is 240, 640 over 240 is 2.66. So that journal's impact factor is 2.66. I think I really do appreciate that humans really like scores and grades and things. They really like this black and white of, I know the value of, the rating of a car based on Kelley Blue Book. They really like to have these comparisons. So I can understand why researchers and institutions would like there to be a number that tells me how good or how prestigious a journal is. But this is very problematic. For me, the most obvious way that this is problematic is that you're basically telling authors that in order to get published in a journal, they should cite that journal in the article, because that then encourages that journal to accept their article because they're getting cited more and their journal impact factor goes up. There are other reasons that this is problematic, but that to me is the biggest one. So the journal impact factor, like I mentioned, the size of the scientific field can play a factor in affecting the impact factors. If you have a really niche field and there's only a handful of journals that cover your topic, your impact factor is automatically going to go up because you're going to be cited more because there's hardly anywhere else to get published in. But then there's also the issue of the age of the literature cited, because if after 2 years, if my article isn't getting counted for the impact factor, then my article doesn't have value according to this system that you're telling me. So there are factors and issues, obviously. The use of the journal impact factor can help in evaluating the impact of journals. It is used in evaluating the impact of scholars for promotion and tenure purposes, and also in some cases for recruitment. Some institutions will hire researchers if they already have a high impact number. But it's really not an indication of quality, in my opinion, and according to science. It's really not evidence-based. This journal impact factor is problematic in so many ways. Okay, I have to keep moving the little boxes around. I know, I can do this and there we go. So that was one, journal impact factor is one way in which we measure measure journals. There's also journal-cited half-life and the eigen or eigen, I can't remember how it's supposed to be pronounced, factor. In terms of time, I'm not going to read through it, but the journal half-life, rather than taking the last 2 years, it kind of takes the median age of articles throughout their publication, and then the eigen or eigen factor score looks at 5 years. So it's going a little bit further back in time. And then on the right, we have from the journal citation reports. I looked at biology. I just took a general science field, but I looked at the top 10 journals in biology, and you can see their total citations, the journal impact factor, and then their eigen factor score. So there are 2 different numbers, but they are related. And again, they're numbers that don't really make that much sense overall. There's also the SJR, which again is a number. And my issue with the SJR is that although you can look up these numbers, whether or not you have a subscription to Scopus, which is owned by Elsevier, the data that they are showing you comes from Scopus, which you have to have a subscription to in order to look at that data. So it's not very open, and I have issues with Elsevier in general. And the SGR, there's also the Google PageRank algorithm, and that is talked about here. So the H5 index, again, looks at the last 5 years of the publication's history. So an index would be that the number of journal, so 60 means that the journal has published 60 articles in the previous 5 years that have 60 or more citations each. So if you look at Nature, an H5 index of 376 means that in the last 5 years, those 376 articles have been cited at least 376 times, which is a lot. And then the median looks at over years. There's a median number. Again, math is not my strong suit, but really it's looking at the number of citations and it's looking at over a period of time. So that's for journals. You can also look at individual authors and their individual metrics. But this is still based on citations. So this is still the traditional journal impact factor world that we're talking about. So the H index for authors is also called the Hirsch index, but it's also based on citations. So a scholar with an H index of 6 has published 6 papers, each of which has been cited by others at least 6 times. How is this problematic? Again, the most obvious thing to me is that a lot of authors will cite themselves. So if I have 10 journal articles and I cite myself each time, so I write a paper, I get it published, I write another paper, I cite that first one, I write a third, I cite those first 2, I'm gaming the system. Also, if Emily and I co-author a paper and we end up citing each other or each other's previous works because we like each other and we want to help each other out, we're still gaming the system. So it's really not based on what we're writing and what we're producing and how important that is. It's just a number, unfortunately. Google also has its own I-10 index, which identifies how many articles published by an author has generated at least 10 citations. So I find this, again, problematic, and there are various reasons for it. As you can see in the cartoon, it's hard to see because of the stock thing about over it, but it says, "Struggling scientists, please cite my papers." Because as problematic as this system is, it's still being used to judge people's work and to, in some cases, grant them grant funding money, in some cases getting them promoted or getting them tenure. And it's not the only factor. There are other things that go along with it, but it really is still a measure that is being used. And then, of course, the problem is that you have to have these tools and you have to have access to these tools. So proprietary tools, Web of Science, and Elsevier Scopus our two proprietary tools. TAMUCC subscribes to Web of Science. We do not subscribe to Elsevier Scopus. And then again, there are open tools, the SJR, which again, their data comes from Scopus. So even though the tool itself is open, the data that they're getting from is closed, and you can't look at that unless you subscribe to Elsevier. And Google Scholar, which of course we could talk about issues with Google Scholar and their algorithms and whether or not it's open and fair and all of that. So what are people doing about this? A few years ago, there was a group of researchers who got together and there was a declaration on research assessment. And they said that a bunch of people are responsible and should be responsible, and we should hold each other accountable. So for organizations that supply metrics like Web of Science or Scopus, they want them to be transparent. They want to provide access to data. They want to discourage data manipulation, and they want to provide different metrics for primary literature and reviews. And this is because if it's primary literature, there's nothing to cite because there's no going backwards in time. For publishers, obviously, stop promoting journals based on impact factor because we know it's problematic and manipulated and a whole bunch of other things. But focus on article level metrics. So not the journal as a whole, but focus on the individual articles and how can we judge those individual articles. Authors contribute in a lot of different ways. They might write a paper, they might serve as a peer reviewer, they might serve as an editor. So publishers should really acknowledge authors and scientists and researchers for all of the different parts that they play in publishing. And of course, we want citation data to be open. We want to be able to look at the data. And again, primary literature citations, not just looking at secondary literature, but looking at that primary literature. And then funding agencies. I mentioned before, grant funders might look at the GIF, and the DORA group really wants grant funders to get away from that. And again, they want to value all outputs and outcomes generated by research. So this could include data sets. It could include negative results or inconclusive results. Just because something positive doesn't come out of a research study doesn't mean that nothing came out of it. And that's still important to note. And then for researchers, for individual authors, focus on the content, not on where you're getting published. Cite primary literature, not just literature that's been cited 1,000 times before. Look at different metrics to know how your work has impact and change the culture. And this is really hard to hold researchers accountable to because they just want to get published, right? So we have to look at research institutions and we have to look at hiring and promoting practices and not focusing on these arbitrary artificial numbers like the journal impact factor. And really, so researchers, if they are faculty, need to work with their colleges, need to work within their field to kind of change the culture of what is it that we value. So in terms of, recruitment, promotion, and tenure, what are we valuing when we say we want you to do research? Do we want you to just get published in a prestigious journal? That just seems like a vanity project, right? But we want to do research, we want to move the conversation forward, and we want people to make an impact in their field, not just look pretty because they were published in some fancy journal. So it's really an ecosystem. Scholarly communication is an ecosystem. We all rely on each other. And so in order to change the focus, everyone has to play their part. So in terms of how do we measure people's works then, this is where alternative measures or AltMetrics comes in. So AltMetrics is the quantitative and qualitative data that are complementary to traditional citation-based metrics. The goal is to broaden the scope of metrics for scholarly impact. So looking at more than just citations, in terms of how we measure research. So they want to focus on other types of indicators, so not just citations, but in terms of journal articles, look at page views and downloads, saves to social bookmarks and online reference managers like RefWorks or Zotero, Social media, it's a huge part of our life. Twitter, I follow a lot of librarians in my field on Twitter, and I read things and find things out. My last slide includes an infographic that a former classmate of mine shared this morning, and I asked her if I could borrow it. Facebook mentions, and then non-scholarly indicators like blogs, Wikipedia, mainstream media, and public policy documents. So this might actually relate to your work, Daniel. But this is still problematic, right? How many times have you downloaded an article and put it in your to-read folder, and then you never actually read it? Tweets, just because somebody tweets something doesn't mean they are actually going to read it. It doesn't mean they're actually going to cite it if you're still considering traditional citations as part of your work. I attended a webinar last week, and somebody did a study and looked at papers that had been tweeted and if they were cited by the user that tweeted that article. And I forget exactly the scope of their study, so I apologize for not having all the details, but they said that only 10.6% of tweeted papers also were cited by the user who tweeted it. And then if you take out self-tweets, so I tweeted about an article I wrote, that drops to 4.89%. So there's still, they're still trying to tie this back to, well, if it's tweeted, it's going to get read, it's going to get cited. But that still is problematic because you're still looking at the end goal of being cited as what you're looking at for the standard. Blogs, I read about research on blogs all the time, but it's not a traditional citation. So it is considered an AltMetric. The mainstream media can be problematic, particularly because if you're writing an article for a journal, you're writing for that journal audience, which might not be mainstream consumers. And so a lot of times things can get, kind of lost in translation. And we've seen that a lot with COVID and misinformation and miscommunication of, can I take ibuprofen if I have a fever, if it might be COVID? Earlier this year, there was an article that was put out that somehow got interpreted as there was a correlation between HIV and COVID-19. The author, it was a preprint, so the authors were able to pull it down and kind of rewrite what they said, because that's not what they said, but that's what the mainstream media interpreted as saying. So there, again, scholarly communication is a whole ecosystem, and there are issues. But the purpose of doing science, of doing research and publishing, is to move the conversation along. It's for the benefit of the whole. Obviously, there are also, personal things like promotion and tenure. But if you're doing research on COVID-19, hopefully your end goal is to help folks understand how to prevent it or create a vaccination for it. And so we need the mainstream media in science to kind of, get our ideas out there and the science out there. But there are also problems in translation. So that's kind of a little off topic, but I think important to mention. So what are the AltMetric tools that are out there? So there are several different things that are out there. Impact Story is a free resource. Scholars can set up their profile, and they have a unique URL, and it can integrate different resources of AltMetrics data. The example I have here is based on data from ORCID, which is an open source free nonprofit organization. Altmetric.com is a fairly prominent AltMetric tool these days. To the right, you see that there's that number 353. So just like the journal impact factor, we have a number. The JIF is 6 point something. AltMetric has created their own number. And so for this, it is 353 because of tweets, Facebook shares, Google Plus posts. I think Google Plus went away, so this is clearly an outdated graphic. Reddit, news outlets, like I mentioned, and blogs. And then down below, there's 0, but there are citation tools that could also contribute to the AltMetric number. There's also PlumX, which is available via paid subscription, and they're owned by Elsevier, so I don't really care for them. But it does integrate different sources of AltMetrics data into one central scholar level or department level metrics page. There's also the metrics toolkit, which kind of helps individuals look at all of the different options out there and figure out what they want to use and how to kind of translate their impact. And they can also look at their impact as a whole as one author, or at looking at specific outputs, so specific articles or data sets, and how that works for them. So don't judge an article by its journal is kind of the biggest takeaway, or one of the biggest takeaways. So the Lancet is a very prominent journal, but things have been withdrawn or retracted. And this is a really good example of that. And then over on the left, I have a YouTube video. It's 2 minutes. But it kind of talks about the bigger issue of academia and the barriers and publish or perish and that whole issue. And then there's an article, obviously, one of the biggest, miscommunications of science is the issue of vaccination and autism, the so-called correlation between the two. And we know that that was bad science and bad reviewing, and it's been retracted, but it's still a common thing that's talked about. So that's all I had. I went through that a lot faster than I thought I would.